So in continuation of the module 2, that is multi-carrier modulation, today let us have a discussion of peak average ratio, that is PAR. So this peak to average power ratio. Okay. So this is the maximum power of a sample which will be in the OFDM transmit symbol to the average power of that OFDM symbol. So maximum power of a sample to the average power of that OFDM symbol. So this peak average power ratio occurs when the multi-carrier system, the different subcarriers. Okay, so we know that we are dividing the wide frequency band into L levels of narrow frequency band. So whenever the different subcarriers are in out of phase with each other, this peak average power ratio will occur. And this orthogonal frequency multiplexing signal will have high peak to average power ratio, so that the efficiency will be reduces, and also the cost of that radio frequency power amplifier is increased, so that this is most expensive component in the LTE transmitter is required. And the same power amplifier, that is PA, it can be used as the input power to the PA, which can be reduced. That is one of the option we are going to be doing, and that is called as what? Input back off. So that if and this also result in the lower average signal to noise ratio at the receiver. Therefore there will be a transmit range in the reduction way. Now we will see what is the problem in peak average ratio. Actually we are using a non-linear device, that we can call it as high power amplifier, or we can take digital to analog converter. Okay, and in this non-linear device we are going to transmit the high peak high amplitude signal. So these devices it will generate a out of band energy, and also there will be a in band distortion. Okay, so this degradation this degradation of the thing will affect the system performance. Okay, so now we all are aware about the behavior of high power amplifier. Okay, that is non-linear behavior of high power amplifier. Now we are going to characterize into amplitude modulation, that is capital AM, and amplitude modulation or phase modulation, that is AM or PM responses. We know amplitude modulation is nothing but amplitude remains constant, and the other two parameters, frequency and phase, will vary, and phase is nothing but phase will remain constant, other two parameters will keep on varying. Now we will see the diagram which will shows the input and output of back off regions. That is, input back off region is represented by IBO, and the output back off region is represented by OBO respectively. Now you see here, in the x-axis we have represented the input voltage, that is as V in, and the output voltage y-axis it is represented as V out. In this V average is also there, peak also we have taken, and the curve is varying in such a way. So now if we consider here, out back of region is there and input back of region, so that linear region. How we have taken up output back of region as well as input back of region, right? Now in the diagram itself you can see that high back of region reduces the power efficiency of the high power amplifier, and also the battery life will be limited for the mobile applications. So there will be the coverage range, right? The coverage range is reduced. The cost of the high power amplifier is higher than the mandatory average power requirement, so that we are going to define the input back off region by using a mathematical expression that is nothing but input back off region is equal to 10 to the log to the base 10 and p in sat divided by p in. So this is nothing but the formula or which is used to analyze the input back off region. And followed by this, we are going for some other peak average ratio reduction techniques. So here first we will see the clipping techniques. So clipping techniques, what we will do by the name itself, we have already studied clipper clamper. So we can give a judgment that the apart from the threshold level, whatever the high peak, it has been clipped. Okay, and there is a minimal distortion of the signal. Sometimes this clipping itself called as soft limiting, because it truncates the amplitude of signals that exceed the clipping level as x bar of n is equal under the two conditions. Suppose if x of n is greater than a, that is a into e power j and the angle of x of n. But if it is less than or equal to a, the x cap of n is equal to x of n. Then followed by this, x of n is the original signal and x cap of n or x bar of n is the output after clipping, and a is the clipping level. So the maximum output envelope value. Okay, so that the clipping ratio can be used as a metric and also defined as the formula, that is so that the clipping ratio, what it will do, the clip by using the clipping techniques, we are going to trying to reduce the peak average power ratio. So in order to prevent the peak average power ratio, we will go for the other techniques like clipping. One more is clipping, and some of the few techniques will be there. It can be adopted in the wireless communication channel. Let us see the block diagram once again. And also apart from this high peak average power ratio is the major disadvantage in OFDM, that is orthogonal frequency division multiplexing. So that what we are going to do in the sense, to overcome this, we are going for the orthogonal frequency division multiple access. Here already in the fifth module we have discussed clearly that frequency division multiplexing is one of the major PAPR is the major disadvantages. So to overcome this, we are going for the other techniques called orthogonal frequency division multiple access. So followed by this PAPR problem, the first technique is clipping techniques, and other reduction techniques is like using additional studies in OFDM systems like iterative clipping and filtering, or peak cancellation or peak mapping. These are the other techniques for reducing the PAR. We call a cubic metric, and also active constellation extension. So these are the techniques can be applied for the reduction of the peak average power ratio. So what is the problem happened in the orthogonal frequency division multiplexing? We understood. Hope everyone understood the concept of problems in the peak average ratio and the methods which we follow in to reduce the peak average